today we will talk about introduction to scientific programming in Python. I have so limited time, so I will try to go as fast as possible to be able to complete in time and to answer your questions before my session ends. And I would like to talk about myself a little bit. I am Ayse Bilge Gunduz. I'm a PhD candidate in computer engineering department in a university at Istanbul. I am an active member of a couple of women-oriented technical groups, and I'm interested in application security, and I'm a huge data science enthusiast. And if you would like to follow me, you can either follow me on Twitter or Medium. So why Python at the beginning? Because it's relatively easy to learn and fast to write a code. It's like writing it in English, it seems to me at least, and very intuitive. And when we compare with Matlab and R, it's versatile. And of course, when we compare with C, it's worse performance. So why Python 3? Because today I will explain everything in Python 3 because Python 2 is not supported anymore. So if you're still using Python 2, I highly recommend to convert to Python 3 because it's easy. So I'd like to start first with Numpy. And Numpy is a fundamental package for scientific computing in Python. We can easily import Numpy with an alias, as we can see it in here, and in the first line. And it's an n-dimensional array object in essential in the core. So we can easily assign a number in any type. It can be integer, it can be float. And there's many functions in Numpy, like in math library in Python, like there's an exponential function, absolute function, as we can see it in here. We can easily reach and with np.pi, np.e number, and pi number, and here are the outputs for our inputs. And okay. We told that it's an n-dimensional array object for Numpy, right? So it's so easy to use with, especially with in array manipulation things when we would like to do. Like we can define an array easily. We can define a data type. It is referred to data type. And we can use print function to print the array itself easily, like in the output we can, I hope you can see it in here. And we can ask to see the dimension of the array itself. It is 1, as we can see it in here. And we can easily get the shape, which is 4. You can see above, like there's a 4 item in our array, and we can ask data type as well, which is a float. So as I told you before, it's an array object. If it's one-dimensional, we can easily call it as vector. So if we would like to do some actions over our array, one-dimensional array or vector, whatever you call, it is so easy. So I create a figure in here to show directly by writing A. We say, I mean, this is an, we call it A, like we did in here. So I'm calling as A. Or we can write A and brackets and colon in the middle. It means that whole items in the array. And we can, if we would like to specific indices in the array, we can easily write the index number like we did in different languages, programming languages. So this is the 0, this is 1, this is 2, 3, and 4. If we write 1, then we can reach the 2. So we can ask for example, like in here, between 1 and third indices, the whole item between 1 and third one. Like in here, we can directly ask like that, a brackets 1 to 3. Then it will give us 2, 3, and 4. And also we can ask for even intervals. If we put 2 colon between the brackets after writing the name of the variable of an array, of course, it means that start from the 0, and with every 2 interval, give me the item in my array, for example. So it will start with 0, we will see 1, then pass to the first index and will give the second one, and we'll pass to the 4 item and we'll give the 5 one, as you can see it in here. So it is because we gave 2 as a parameter in here. And we can create even diagonal matrices easily, and matrix full of zeros or ones with Numpy. As you know that NP stands for Numpy, since we imported as import Numpy as NP. np.diag will give us a diagonal matrix. What is diagonal matrix? If you ask, a diagonal matrix is outside of main diagonal is whole 0, but the main diagonal will include values in it. It's a in default the diagonal matrix. So we can create a normal diagonal matrix like in the first line in our code, or we can create the offset ones as well. And if you wrote k equal to 1, it will create a first offset like in D2. The first column will be our offset, then the diagonal matrix will be created. And also, as I told you before, we can create matrices full of zeros, like it is 5 refer for the row number, 4 refer to the column number. And in NP1s, this is the second one, M2 in output, which has 2 rows and 3 columns in here. So there is also, as I told you before, there is also array manipulations, right? Because in Numpy, everything is n-dimensional array object. If we name our variables as m, we can call directly by writing m, or we can put brackets after m, after variable name, and put comma, colon, then in between comma. If we want to access the specific instance in our array, then we can give the row and column indices to reach out to access that instance, or we can directly ask to reach to the full row, for example. The first row I want to reach, then the third example will show up. And as you can see, I'm going from top to bottom, then we'll pass to right one and bottom again as well. And the first row you can easily reach by writing m brackets 0, so as you can see it in the bottom right one, -2 means the first row actually, and we can see that there's after comma there's a colon actually. The colon means the whole row except whole column, except the last one. So there is many matrix manipulation functions in Numpy. So you can ask shape easily, like a.shape, and it's so similar in MATLAB. And also a flatten function will give a copy of our matrix, just is a flattened way, as we can see it in the bottom in our output. So there is a Matplotlib library as well. standard to import Matplotlib like that. And as you can see it in here, we plot that figure, we create a figure, then we start to fill inside of the figure. We say that plot according to X1 and 2, and R means red, with color as red. And X label and Y label means the title of the labels. And also we can give a title to be able to display our Matplotlib figure. Seaborn is so attractive, so nice. I love to use it. The library is based on Matplotlib. You can easily use like import Seaborn as SNS.sat. I load an iris dataset in here. You can see the dataset with rel plot. Here you go. It's a lovely, really nice and attractive figure. We can see it in here. So I want to pass directly to Pandas because there's so many things that I'd like to share. First of all, Pandas is a data frame object. What is data frame? If you ask, you can consider like data frame is an Excel sheet. You can consider like that, or a dictionary in Python of the series object. So you can import pandas as PD. You can call different aliases, but PD is so standard. And you can read and write many file types with pandas. Like I read a Pokemon CSV in here. I even can give as a parameter to encoding. And the hat will give us the first 10 rows in our data set, like as you can see it in here, I hope. And the first one is Bulbasaur, the second one is Ivysaur, and there's Charizard in here, and there's many information attributes about the Pokemons. We can see it in here. And I'd like to give more profound examples by using Matplotlib, Seaborn, and Pandas from this point. Matplotlib inline will give us a rendering figure in notebooks. After my session, I will share my notebook Google Colab notebook with you. There's many more examples in it. So as we can see it in here, we read again the Pokemon.csv, and we said that there is a column information inside our data set, and we said that with head function, we would like to read the first 5 row in our data set. And there's a group by function in Pandas. As you can see it in here, we set type 1 with type 2. It means group by type 1 with type 2. Type 1 is the primary one, type 2 is the secondary one. So it's a type 1 says it's a bug, it can be bug, it can be water, it can be poison, like that. And type 2 will reveal the type 2 of our Pokemon in here. I'm checking the time as well. So the group by ends with type 2 actually. We just group type 1 and type 2 by asking the speed and mean function. We say that according to type 1 and type 2, we ask to the average speed to the type of that Pokemon. For example, and type 1 is bug for Butterfree and Ladybug, and both in their type 2, it's also flying. And what if we want to know the how many null value in our feature set, in our data set in features? We can ask with Pokemon.isNull. And with that sum, we can ask the summation for each features. By the way, as you can see it in here, I don't know if I wrote it, the data set is from Kaggle. I will share it later if I didn't share it in here. And then I wanted to see the Pokemon's I wanted to see every type of Pokemon according to type 1, let's say. The first 2 lines are the options to make it more nice to Seaborn library. Plot figure is create a plot for us in a figure size. And I'm saying that Pokemon type 1, I wanted to reach out in our data frame and count the values of that type 1 and plot a bar and make the title, set the title as Pokemon types, like in a font size. And let's run it. When we run it, as we can see it in here, we have water Pokemons, we have flying Pokemons, but mostly water, then normal, least flying Pokemons, like that. So we can say that how many legendary Pokemon exist in this list, for example. Legendary is a false and true options. If a Pokemon is legendary, it says it's true. If it's not, then it's false. Okay, let's see that there is 700 non-legendary Pokemon and 665 legendary Pokemons. And in legendary Pokemons, we want to see the type 1s. And when we check that with value counts, we see that mostly legendary Pokemons are Psychics and then Dragons. So my time is done in here. Unfortunately, I had many more things to show you, but the time is up. Thanks for listening, everyone.